Welcome to The Explainer. Today, we're going to pull back the curtain on the invisible magic behind your 5G connection. And we're going to do it by taking a look inside a truly groundbreaking project, India's very first homegrown 5G network. You know, it feels completely instantaneous, right? You tap the screen, and it just works. But what's really happening behind the scenes? Well, that simple tap kicks off an incredible high-speed journey through a network that is way more complex, powerful, and honestly, more fascinating than you might think. Okay, so let's break down that journey. It's basically a four-step process. First, your phone talks to an antenna. Then, that signal gets processed by a powerful computer. And finally, the network's brain figures out who you are and connects you. We're going to walk through each of these steps, starting right where the magic begins, at the antenna. All right, let's start with the part of the network you can actually see. The antennas perched on top of all those cell towers. These are the front door to the network, the crucial first link that sends and receives the radio signals that make this whole thing work. So the first thing you'd notice if you put a 4G and 5G antennas side by side is just the sheer density. We're talking about a jump from maybe a handful of elements in 4G to as many as 64 in a 5G setup. That's a massive leap in complexity, and there's a really smart reason for it. Okay, so why? Why cram so many tiny antennas together? What's the point of all that complexity? Well, it all comes down to making the network smarter, more efficient, and incredibly focused. The secret sauce here is a key 5G technology called beamforming. Think of it like this. A 4G antenna is kind of like a bare light bulb in a room. It just blasts light, or in this case, data, in every direction. It works, but it's super wasteful. A 5G antenna, with all those elements working together, acts more like a spotlight, forming a concentrated beam of data that it can aim precisely at your phone. And this quote just nails the concept perfectly. Instead of shouting in all directions and hoping you hear it, a 5G tower looks at your phone and speaks directly to it. This focused energy means a stronger, more stable, and way faster connection, all without wasting power broadcasting into empty space. Okay, so once that super focused beam hits your phone and your signal goes back to the tower, what happens next? Let's follow the signal as it travels down from the antenna to the network's digital engine on the ground, the baseband unit. This box is the real workhorse, the unsung hero of the cell site. It's both a translator and a traffic cop. It takes the messy radio waves from the air and turns them into clean digital data. At the same time, it's managing all the chaos, assigning you a clear frequency, boosting your signal, and, this is crucial, filtering out all the random noise from the environment so your call is crystal clear. And get this, it does all of that at a speed that is just mind-bending. The unit is constantly doing something called channel estimation. It's figuring out the absolute best, cleanest path for the signal to travel between you and the tower. And it does this every half a millisecond. To put that in perspective, a single blink of your eye takes about 300 milliseconds. So in the time it takes you to blink once, this unit has reanalyzed your connection 600 times. And that right there, that constant sub-millisecond checkup, is the secret to 5G stability. It's exactly why your connection doesn't drop when you're in a car or on a train. The network is recalculating the best path to your phone faster than your brain can even process. So our signal is clean, it's digital, it's processed. Where does it go now? Well, it's sent to the final stop, the brain of the entire operation, the 5G core network. That's the perfect way to put it. You know, if the antennas are the eyes and ears scattered everywhere, the core network is the central nervous system. It's not at any one tower. It's a powerful, centralized system that runs everything for an entire region, sometimes even a whole city. This is basically mission control. It's where the network asks, who is this person? Are they a paying customer? What kind of data plan do they have? And then it makes the big decision. Okay, let's route this data to the internet so they can watch YouTube, or let's connect this to another phone for a call. It manages all the high-level logic for every single person on the network. Now here's one of the most revolutionary things about 5G. This entire brain is just software. That makes it incredibly flexible. I mean, look at this. You can run the exact same core software on a simple laptop to serve a dozen people in a lab, or scale it up on a server for a whole campus, or deploy it in a massive data center to connect millions of people across an entire city. So now that we understand the technology, let's talk about the incredible human achievement behind building this entire system from the ground up, right here in India. This didn't just happen overnight. This was a 4-year marathon. A group of Indian institutes brought together this dream team of experts. You had mechanical engineers designing the physical boxes, radio frequency experts tuning the antennas, and software teams writing millions of lines of code to bring the whole thing to life. And after 4 long years of designing, building, and troubleshooting, it all came down to this one moment. They'd been struggling with some tricky power settings. The team came in, tried again, and suddenly, a regular off-the-shelf smartphone connected to their network. It just worked. Can you imagine that feeling? That was their eureka moment. But you know how it is with technology, right? The work is never done. With 5G becoming a reality, these same researchers are already looking ahead to the next generation, asking, okay, what problems will 6G need to solve? And this slide shows the huge shift in thinking. See, 5G was fundamentally built for us, for people, to give us faster streaming, better video calls on our phones. But the vision for 6G is completely different. It's being designed for machines, for a future where billions of devices, from cars to factory robots to your smart toaster, are all talking to each other. And to build that machine-to-machine world, they're tackling some massive challenges. They have to make the network itself more efficient, to free up bandwidth for all those devices. They're trying to build AI directly into the network's brain just to manage all that complexity. And they're working on location tracking so precise, down to the centimeter, that it could guide autonomous robots in a warehouse. And this really captures the ultimate change. The network stops being a one-way street where we mostly just consume data. Instead, it becomes this dynamic, two-way web where billions of smart devices are constantly talking to and learning from each other. It's a pretty profound thought to end on, isn't it? We've gone from the mechanics of your phone call today to imagining how our entire interconnected world might work tomorrow. Thanks for watching.